right, now we're moving on to worksheet 67. This whole front side is all perfect squares, so we're not really going to spend time explaining it. We have the perfect square chart as note sheet number 2 in our notebooks, so you could always use that if there's any perfect square questions on the final. 64 has roots of 8 and 8, so we got plus or minus 8. 25 has roots of 5 and 5, but there's a negative sign in front, so our answer is not going to be plus or minus 5. It's just going to be negative 5. Number 3, we got negative 13. Number 4, we've got, well, 4. Number 5 is a little bit tricky. The only two numbers that multiply to get 0, well, that are the same number are 0 and 0. So the square root of 0 is just 0. Now we don't need to put a plus or minus in front because 0 can't be negative. Or positive, really, for that matter. It's kind of just right there in the middle. Number 6, we got a negative in front, so our answer is going to be negative 6. Number 7, 81 has roots of 9 and 9, so we got plus or minus 9 there. 8, we get negative 10. And then when we have fractions, remember we want to split it up. So root 4 over root 144 gives us 2 over 12. But we can simplify 2 over 12 further and get plus or minus 1 over 6. Right? 2 is 2 times 1. 12 is 2 times 6. Cancel out the 2's, and we're left with 1/6. Over here, same thing. We're going to split it up. Root 121 over root 196 gives us, what, 11 over 14? Can't simplify that anymore, so we'll leave it how it is. And we have a negative in front again, so there's no need for a plus or minus sign. Down here, we've got 2 over 14. That'll simplify to 1 over 7. And over here, we've got negative 1 over 11. Nice and easy, perfect squares, self-explanatory. But now we're going to have to estimate some square roots. So we got some imperfect squares here, also known as irrational numbers. And we have to estimate. So remember, estimate does not mean we're going to make a factor tree, Doesn't mean we're going to make a factor tree. It means that we need to figure out which two perfect squares fall on either side of this number, and that's going to give us our answer. So we can start by thinking, well, what's the closest perfect square to 228? In my mind, that's 225. Right? And 225 gives us a root of 15. 228 is going to be right after that. And then what's the next square root after 225? Or sorry, the next perfect square after 225? Well, it'll be 16, which is 256. And again, that gives us 16. So our answer is going to be, if we want to estimate the square root of 228, it's going to be somewhere between 15 and 16. Between 15 and 16. Whenever we're asked to estimate, our answer is going to be between. Square root of 10. The closest perfect square I can think of is 9. And right after that is going to be 16. So the square root of 10 is going to fall somewhere in between 3 and 4. Between 3 and 4. Moving down to 15, 83, the closest perfect square is 81. And right after that would be, what, 100? Yep. So we're going to be between 9 and 10. 105, the closest perfect square is 100. Right after that would be 121. So we're going to be between 10 and 11. 26, that falls between 5 and 6. And 66, that's right after 64. And right before 81. So somewhere between 8 and 9. So if we plugged in the square root of 66 into our calculator, we'd get 8 point something. That's what this estimation means. But we're not always going to be asked to estimate. Sometimes we're going to be asked to simplify. Now, if we're simplifying a square root, that means we have to break it down, create a factor tree, and then take out any identical pairs that we might have. Identical pairs of factors, I should say. So let's break up 48. That's going to be 4 times 12. 12 is 4 times 3. 4 is 2 times 2. And 4 again is 2 times 2. So we got all five of those prime factors. We can rewrite this as 2 times 2 times 2 times 2 times 3. And now we're looking for identical pairs. We got a pair of 2's and another pair of 2's, and both of those pairs need to come out in front. What number is left over inside the square root? Well, that's going to be 3. So now the question is, what do I do with these two 2's? I brought out one pair of 2's. I brought out another pair of 2's. When we bring out a pair, they kind of fuse together and form one singular 2. And then we're going to multiply them when they're out in front, just like we were multiplying them inside the square root. And we get plus or minus 4 root 3 for our simplified answer. Don't forget the plus or minus in front, because we could have easily taken out a negative 2 times negative 2 and got negative 4, right? All right, let's break up 84. 84, that's going to be, what, 7 times 12? 12 is 3 times 4. 4 is 2 times 2. So this one we've got 7 times 3 times 2 times 2. We've got a pair of 2's that can get brought out. And what's left behind now is a 7 and a 3. So just like those two 2's that we brought out in front and multiplied them, we're going to keep the 7 and 3 inside the square root and multiply them to get 21. Now we brought a pair of 2's out in front. That's going to give us plus or minus 2 root 21. Forgot to circle up my prime factors, but there's all 4 of them right there. We got the square root of 50. That's just 5 times 10. 10 is 5 times 2. We got a pair of 5's and a 2 left over. So our answer is plus or minus 5 root 2. 12 is 4 times 3. 4 is 2 times 2. 2 times 2 times 3. Bring the pair of 2's out. 3 gets left behind. Plus or minus 2 root 3. Once you really start getting comfortable with this stuff, you're going to jam right through it. Now 250, we can think about this a bunch of different ways. I'm going to go with 25 times 10. That makes the most sense to me. And we break it down like that. 5, 5, 5, and 2. So now we have a pair of 5's. Even though we have triplets, we have 3 5's in here, we can only bring them out in pairs, which means that 5 times 2 gets left inside the square root, and that gives us 10. 27, 3 times 9. 9 is 3 times 3. Again, we can't take all 3 of these 3's out. We can only take a pair out, leaving us with plus or minus 3 root 3. All right, second page. That was a lot for the first page only, but second page, we're still simplifying here. 8, 4 times 2, 2 times 2, plus or minus 2 root 2 is our answer. I'm going to kind of breeze through these now. We're getting a little bit quicker here. 148, ooh, that's a hard one. I'm going to just cut it in half real quick. What am I going to get? 74. Cut 74 in half again because it's an even number, and what am I going to get? Well, 35 plus 2, 37. And 37 is a prime number. We can't split that up anymore. Pair of 2's gets brought out. 37 left behind, plus or minus 2 root 37. $99. We can do 9 times 11. 9 times 11. 9 is 3 times 3. 3 times 3 times 11. We bring those out. Plus or minus 3 root 11. 96. Can't divide it by 9. Can't divide it by... We can divide it by 2, I guess. Yeah, let's divide it by 2. So we get 2 times 48. 48 is 4 times 12. 4 times 3. 2 times 2. 2 times 2. Wow, what a crazy factor tree that one was. Let's try and figure out where all our prime factors are. There we go. So this is 2 times 2 times 2 times 2 times 2 times 3. Wild. Pair of 2's gets brought out. Another pair of 2's gets brought out. We're going to multiply them in front, and we'll multiply the 2 numbers left over, giving us, of course, 2 times 2 gives us 4 root 6, just like that. Moving on down here, 56 is 7 times 8. 8 is 4 times 2. 4 is 2 times 2. Okay, pair of 2's gets brought out. 2 times 7 left below, plus or minus 2 root 14. And finally, 24 is 12 times 2. 12 is 4 times 3. 4 is 2 times 2. Boom, 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 boom. 2 times 2 times 2 times 3. Bring the 2's out. 2 times 3 left behind, plus or minus 2 root 6. Moving on down, distance on a graph. So we got some nice notes here on this in our notebooks. All we have to do is count the legs of our triangle. Let's say we're making a triangle here with this line. And the distance that we're looking for is C. It's our hypotenuse, directly across from our right angle. Well, how long is this leg? It looks like it's 1, 2, 3 units long. This leg is 1, 2, 3, 4 units long. So we can use a squared plus b squared equals c squared to try and find what c is equal to. We get 9 plus 16 equals c squared, which is 25 equals c squared. And then we take the square root of both sides and get c is equal to 5 units. Same thing here on 32. We're going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we got to find C. 5 squared plus 5 squared equals C squared. 25 plus 25 equals C squared. And we get 50 equals C squared. And I think, didn't we do the square root of 50? I think on the other page. Sounds familiar. Yes, we did. Square root of 50 is equal to 5 root 2. So that's what we're going to get over here. When we square root both sides, we get C is equal to 5 root 2 units. All right, finally to the back here. Just a couple distance formula problems. We'll finish out with this distance on a graph here. Now, it doesn't really matter if you make your triangle, going up or going down. You're going to get the same leg lengths either way. This one here is 1, 2, 3, 4, 5, 6. This one's 1, 2, 3. 3 squared plus 6 squared equals c squared. 9 plus 36 equals c squared. 45 equals c squared. And then we take the square root of both sides. 45 is 9 times 5. 9 is 3 times 3. So we get c is equal to 3 root 5 units. Don't forget units, we're talking about distance, so we need units. No plus or minus needed, though. Finally, over here we got 1, 2, and 1, 2 for our little triangle. 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. 8 equals c squared. Square root both sides. C is equal to 2 root 2 units. down here. Now we're doing real-time distance formula. First thing we have to do, of course, is label each of these points. Let's get this in focus here. There we go. We're going to label them x1, y1, x2, y2. And we're going to plug them in. x2 minus x1 squared plus y2 minus y1 squared. x2 is negative 1 minus x1, which is 5. y2 is also negative 1 minus y1, which is 7. Negative 1 minus 5 more is negative 6. Negative 1 minus 7 more is negative 8. We get 36 plus 64, which is 100. Then we take the square root of both sides and find that d is equal to 10 units. All right. 36. x1, y1, x2, y2. d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Now, something I want to point out here is we got to be careful about these double signs in there. We have to have a minus sign in between our two terms when using the distance formula. But if we're subtracting a negative number, we have two minus signs together that form a plus. 2 minus 5 is negative 3. Negative 6 plus 3 gives us negative 3. We get 9 plus 9, which is 18. And when we take the square root of both sides, we get d is equal to 3 root 2 units. Just so you know, 18 is 9 times 2. 9 is 3 times 3. There's my pair. There's my leftovers. Down to 37. x1, y1, x2, y2. d squared is equal to x2 minus x1. Again, double negative signs. Plus y2 minus y1. Those make a plus, giving us 12 squared plus negative 8 squared. 144 plus 64. When we add those up, what do we get? Like 208, I think? Sounds about right. Yeah, 208. Let me just make sure here. I don't want to tell you all the wrong information. What did I do wrong? Oh, where did negative 2 come from? Oh, that should be negative 3. My bad. Negative 3 minus 6 is negative 9. That gives us 81. And that gives us, there we go, that makes more sense, 225 now. I apologize. If I can make a mistake, so can you. So you definitely want to double check your work, right? Square root of both sides gives us d equals 15 units. And over to 38. x1, y1, x2, y2. x2 minus x1 squared plus y2 minus y1 squared. We got a lot of double negatives going on here. Make those plus signs. 1 squared plus negative 6 plus 7 gives us 1. So we got 1 plus 1, which is 2. Square root both sides, d is equal to root 2 units. And that's all we can do there for that one. So that's worksheet 67. I know we went through that kind of fast, but a lot of it we've talked about for weeks and weeks and weeks, so we kind of don't need too much refreshing. But there it is. If you have any questions, please let me know.